Good morning, everyone. Okay, so today we are going to discuss equations and graphs of velocity in simple harmonic motion, and then we'll go over to acceleration as well. So let's start. Okay, so first of all, we will begin with the equation of position, right, at any time t. The position is x equal to a sine omega t plus phi 0. Right? This equation is what we are going to use. Right? So from position, we will try to find out velocity, which is very simple. I am sure everyone realizes that all we have to do is differentiation of this equation. Right? So let's start. Now first of all, when you try to differentiate this, a is a constant, right? So you can keep the constant out and then worry about the remaining. Okay. Now, once we have this, d by dt, that is differentiation of sine omega t plus phi, right? So over here, you can think of it that this is sine theta kind. Okay, so differentiation of sine theta should be cos theta. So cos omega t plus phi 0. But like I taught you earlier, here this t is multiplied with omega, right? This t is multiplied with omega. So that's why we should multiply omega outside over here. Is this clear? Is this equation that we have obtained clear to you? Okay, so basically this equation is giving you the relation. Okay, I think you should try to remember this. Okay, if you cannot remember, don't worry. Just differentiation of this thing gives you v in one single step, right? So don't worry too much about it. But try to remember if you can. This is giving you the relation of velocity and time. I repeat. This is giving you the relation of velocity and time, right? Velocity v with time t. Other things, they are all constant. Amplitude, omega and phi 0, right? Is it clear? Okay. Now we will go on to a slightly different thing. Okay, we'll go on to a slightly different thing, right? And that is, we'll try to obtain a relation of velocity not with time but with position. Okay, we'll try to obtain relation of velocity with not time but position. So let's start. Okay, so for understanding how to get that, have a look here. Let's call this equation number 1, and let's call this equation that we've got, okay, the one that I've boxed here, let's say this is number 2. Right? Now in both of those equations, do you realize that we have this angle and this angle which is same, that is it, this is sine of that angle, this is cos of that angle. So let me start by saying that phi is equal to omega t plus phi 0. This is just a symbol that I am using. Okay, here you can write theta also, you can write alpha if you want, no problem. Okay, this is let, that is suppose this angle is phi. So then first equation would now become x equal to a sine phi, and similarly second equation would become v equal to a omega cos phi. Clear so far? No? I'm surprised. Only 2 of you understood that? We have just put value phi for this whole bracket, right? That's what we have assumed. That's what we have assumed. Now, we're going to use a little bit of trigonometry here. So, first of all, I'm going to find sine phi from here. So, sine phi is equal to x upon a, and similarly cos phi equal to v upon a omega. Right? Very easy. Right? Sine phi is x upon a, and cos phi is V upon A omega. Now, I'm sure everyone remembers that there is a simple relation between sin theta and cos theta that we have learned in 10th standard. It is that cos square theta is 1 minus sin square theta. Do you remember that? Or basically sin square theta plus cos square theta equal to 1. ओके एना वगैरह तो તમે 10th પાસ નહીં થયા હો બરાબર ને okay so here instead of theta we have phi no problem doesn't change anything right let's put these values so what is cos square phi v square upon a square omega square is equal to 1 minus instead of sin square phi x square by a square you see what I've done. Earlier we got a relation of v with t, velocity with time. But now by putting this equation in this form, I have removed t from here. You see there is no t in this equation, right? There is x though. Let's simplify this a little bit further, right? So v square equal to, I'm going to multiply this a square omega square on that side. So 1 into a square omega square is a square omega square minus x square a square omega square upon a square cancelled right a square is cancelled and then what we have common is omega square. Did you understand this relation? And then I'm going to take square root. So when we take square root we will get plus or minus. See, square root of omega square is omega and square root of this whole bracket is here. This is plus or minus. This is basically same as doing something like if v square is 4, then v could be plus 2 or v could be minus 2 because velocity can either be right side or left side. Okay, so that is what the plus and minus is indicating. Did you understand? I repeat, velocity can either be towards positive or negative side, right? Depending on various situations. So that's what this plus or minus is indicating, right? So again this is the relation of what? Relation of v with x, that is velocity with position. Relation of velocity with position. Completely clear so far? I would say this is must. Okay, you cannot afford to forget this, everybody. It's very useful relation. You cannot afford to forget that one. Okay? In case you forget this, like I said, there's no big deal. You can just differentiate sign and get this thing here. But here we have a few steps and this is used very often. Okay. Again, what does this plus or minus indicate? It's telling you that for one particular position, the particle might be going right side or might be going left side. Okay? I'm raising the left part. Well, so now let's try to see what happens at different points. So suppose here is the region where the particle is moving in SHM, and let's say as usual right side is considered positive and left side is considered negative, right? Okay, so if particle is at mean position, if particle is at mean position and moving towards right side, that is towards E, suppose that is particle is at here and it is moving towards right side, that's towards E. Okay, so let's use this formula and understand what's going on. So at this place here, of course we'll take this as origin. This is x equal to plus a, this is x equal to minus a. So if I want to find v, what should be the value of x that I should put if particle is at mean position? Over here, what value should I put? 0. Very good. X is equal to 0. So now I get omega under root a square minus 0 square. So we get omega into a. Clear? We get omega into a. Now listen to this carefully. What about the minus? Should it not be plus or minus? No. Read the title carefully. Moving towards E. That is moving towards the right side. So velocity's direction is positive. Clear or not clear? Clear or not clear? Velocity's direction is positive. Got it? Okay. One more thing to understand is that when you use this formula, you are actually subtracting x squared. Right? You are actually subtracting x squared. So if you want the maximum modulus, okay, maximum magnitude, forget plus or minus for a second. If you want the maximum magnitude of velocity, then you will have to put x as minimum. Clear? X squared as minimum. Clear? So I am saying that at mean position, as x square is 0, speed, magnitude of velocity is called speed. Speed of particle is maximum. Did you understand? At mean position, as x square is 0. Here you are subtracting and you are subtracting 0. So the particle has maximum speed. How much? Maximum speed Vmax is equal to omega a. Clear? Clear or not clear? Maximum speed omega into a. Wait, just like this, if instead of moving towards E, if it was moving towards E dash, then what would happen? This is going this way. So velocity, this is velocity, okay, then the velocity will be minus omega a. Clear or not clear? Clear or not clear? If instead of moving towards the right side, it was moving towards left side, okay, then the velocity would be minus omega. Speed would still be the same. Speed would still be the same. So, in short, we can write, okay, this is very important. At mean position, speed is maximum. And how much? This much. Understood? At mean position, speed is maximum, right? Whether it's going towards the right side or it's going towards left side, that's okay. No problem. It might go towards right side, it might go towards left side. But speed is maximum at the mean position. Clear? Okay. One more thing. All this is from maths, fine. But if you want to try to get the reason based on physics, that is why speed maximum here. There are various ways to explain. It's that if you think that at some point of time particle was here, let's say, and now it has started to move towards left side. So as it moves towards left side, the restoring force will also be towards left side because displacement is right side. So total force is left side. So what is happening is all the way from E to M, the force is going to pull it. Right? Over here, it starts to move and the force is going to pull it. So if you apply the force all the way from here to here, right? So at this point, the speed will become maximum because gradually the speed will be increasing. I am not talking about maximum velocity, Gracie. Maximum velocity, you can say it is plus omega a or minus omega a. Okay? But generally, we don't talk about maximum velocity, because velocity also indicates direction, right? So just pretty simple, maximum speed is enough, right? Even if the question would ask maximum velocity, then also the answer is omega A only. Is that clear? Even if the question would be maximum velocity, the answer is omega A, because velocity's magnitude can be maximum, direction cannot be maximum. I hope you understand what I am saying, right? So we only worry about magnitude, that is speed. So this is what is going on, right? Now let's go to one of the end positions. Let's go to one of the end positions. Because of opposite force, which opposite force? Think about it carefully. I don't really get why you are saying opposite, but what I mean to say is displacement right side and force left side. So if you are calling that opposite, yes. Okay, velocity is in this direction because it will start moving from here to here to here. And force is also in the same direction. That's why the speed will increase, right? Think of spring, you will understand. Okay. Next, what if it is at mean position? What if it is at extreme position or end point? So let's see what happens at extreme position on either side. Okay, no problem. Let's say E. Okay, x equal to plus a, suppose that is E. So here we have x equal to plus a. So if I put that in the formula of velocity, did you understand what I have done? Okay, so we are getting a result as expected, isn't it? We are getting a result as expected. Do you remember I have told you earlier? Okay, I'll just draw it anyways again. Okay. Do you remember I told you that at the end point, because the direction has to be reversed, over here the velocity has to be 0. Yes or no? Clear or not, everyone? Is this clear? Okay. So this is also worth remembering. At extreme position, speed or velocity is 0, right? Either. Even if I would have put x equal to minus a, do you realize that here it doesn't make any difference? Okay, because minus a square is once again a square. Okay, minus a square is a square, so this would still be 0. So whether here or here, at both these places, the particle has 0 velocity or 0 speed. Okay? So that's what we have discussed earlier. It's that at mean position the speed is maximum, that's this much omega into a, and at extreme position the speed is 0. Right? Okay. Fine, let's solve a question based on all these. Okay, let's begin. You can't read this, I believe. This word is position. This is where. This is first question here, and this is the second question. Okay. Right? Shall we start? Questions here? Okay, so the first one is you have to find speed of particle at time t equal to 0. So obviously to find speed of particle at time t equal to 0, we need a relation of v with t. What's that relation? Can you tell me? Come on everyone. Hurry up. What's the relation of v with t? ગોતો નોટ્સ દોસ્તો આજે જ કરાયું હમણાં જ કરાયું હતું instead of omega you may write w, no problem, everyone. Okay, I will understand that it is omega. So if this is of the type x equal to a sin omega t plus phi 0, then v will be equal to a omega cos omega t plus phi 0. Understood? Right? So let's use that. Come on. So what do we have to find? We have to find speed at what time? At t equal to 0. Very easy, isn't it? Put t equal to 0 and put all the values. How much is a? Can you compare this? Can you tell me what is a? 5. Very good. What is omega? What is omega? What is omega? By comparison of equations. Come on, people. 3. Okay, cos. Over here. Omega is 3, time is 0, plus phi 0 is pi by 4. Right? Okay? So what do we get? 15 and cos pi by 4 is 1 by root 2, 45 degrees. 1 by root 2. But don't forget, this is going to be in centimeter per second. Why? Look at this. Understood? Clear or not clear? 15 into 1 by root 2. Then you can simplify it if you want by putting root 2 value, but I am not going into all. Okay, first part clear everybody? Like this, if you want to find it at any time, okay, you can put that value here and then you'll have to find out the value of this cos. Like here we have to find value of cos pi by 4. It could be any angle, remember. It could be some other angle also. If it's a weird angle, you'll have to look at it in the tables. Do you remember? We have tables for sine, cos and all that. Okay, so you look at it over there. Okay, second part. Come on. Speed of particle when it reaches at midpoint of mean position and extreme position on either side. What does that mean? Can you convert this language to something easy? Can you tell me, by reading this, can you tell me what value of x should we have for this? Okay, very good. Many of you have got the right answer. Congratulations to all of them. Some of you have made some mistakes. Let's clarify. See, this question is telling you that here is mean position, here is end position or extreme position. Where is the particle? The particle reaches the midpoint of mean position and extreme position. Is this clear? Either there or here, no problem. Okay, answer will not change. Don't worry about it. Understood or not? Right here in the middle. So So this will be x equal to plus a by 2. If you take it on this side, then it will be x equal to minus a by 2. Clear or not clear? Any one of them will do. Any one of them. Got it? Well, now once we have a value of x, this is so easy, isn't it? So x is a by 2, right? If we want, we can put a value of a as 5, but I'll do that later. We want to find speed. So how do we find speed? Speed is the magnitude of velocity. So what's the relation of v with x in simple harmonic motion? For simple harmonic motion, what's the relation of v with x? V equal to omega into, I know it's complicated to type, omega into root of a square minus x square, isn't it? Let's put the value. Okay, omega is 3 root of a square minus a square by 4. Okay, so if you take LCM and then you simplify, this will become root 3a by 2. Understood so far? Okay. Right? Just a bit of math. LCM 4 minus 1, 3, 3 square root 3, and a square square root a, 4 square root. Okay. So let's put values. Therefore, v is equal to 3 into root 3 into a by 2. A is 5. And this will be once again in centimeter per second. If you want, you can convert it to meter per second. Okay? Right, so that's what we have. Alright? Now let's go over to the next thing. Try solving this one now. As usual, you draw and try to imagine what is going on. Okay? Hopefully diagram is done. So what it's saying is that suppose to go from E to E dash, going all the way from E to E dash takes how much time? Takes 2 seconds. Right? E to E dash takes 2 seconds. Okay. Now based on this and based on this information, that at the mean position, so while it's moving like this, let's say here at the mean position, right, at x equal to 0, v is equal to 4 meter per second. Okay, using these two things, we have to find out what is the amplitude of its simple harmonic motion. That is, as it starts to move from here to there, we have to find how much is the amplitude. Okay, so we are given this thing at mean position, the speed is 4 meter per second. You know, at mean position, speed is maximum. So what's the formula for maximum speed in simple harmonic motion? Vmax equal to A omega or omega A. Very good. Okay, so we can use that. There's only one problem though. Vmax 4. Okay, because this is definitely Vmax because it's at mean position. What's the problem? We don't know what is omega. For that, can we try and use this information? Can you tell me based on this information how much will be omega? Come on people, use concepts. Hurry up. Omega will be pi. Are you sure? Omega will be 180 degrees. Raj, are you kidding? Omega will be pi by 4. Okay, pi by 2, 2 pi. Okay, we are getting lots of different answers. Pi again, pi by 2. Okay, pi. Let's see. First thing is that to find omega, here you need time period. Okay. So do you realize that time period is 4 seconds? Yes or no? Yes or no? Time period 4 seconds. Not 2 seconds, 4 seconds. Anyone has doubt with 4 seconds? Can you please say doubt in the chat box? Okay, nobody said that. Fine, very good. So t is 4 seconds, so omega is 2 pi by 4. Clear? Because omega is 2 pi by t. Hopefully you remember we derived relation that t is equal to 2 pi by omega. That obviously means omega is 2 pi by t. Right? Okay? So that's it now. So final answer is A is equal to 8 by pi meter. Got it? Clear or not clear? Okay. Now let's go over to acceleration. Right? Okay, I think we have got some feel of velocity. Right? Okay, now acceleration in SHM. Okay. So as usual, we are going to start with the equation. That suppose at time t equal to d, the position is given by this. Okay, like we did for velocity. It's obviously a similar procedure. So first of all, we find v by doing differentiation. I'm just going to write it again. It is a omega cos omega t plus phi. Now, if we have got v and we want to find a, so we'll do differentiation one more time. That is, we'll find acceleration by dv by dt. Okay, as dv by dt. Okay. So a and omega, they are constants, so they don't bother us. Differentiation of cos will be minus sine Understood or not? Okay, and then this t is multiplied with omega. So that omega should be multiplied outside. So here we'll have one more omega. So finally this becomes minus omega square into a sine omega t plus phi 0. Clear what I've done? Again, this omega is multiplied with t, so we have to multiply it outside. So omega into omega becomes omega squared, right? And differentiation of cos is going to be minus sign. Okay. Yeah, I know. That's why I stopped speaking. Okay, that's why I was waiting actually. Okay, now is it fine? Can you see the video clearly? Yeah, okay. So, once we have got this is familiar, isn't it? This is x. Therefore, a is equal to minus omega square x. Understood? A is equal to minus omega square x. Right? So, what we have done now is we have given a constant to that relation. If you remember, so far we were always writing like this. You remember that? So far we were always writing like this. Yes or no? So now we know that if you don't want the proportionality, then you can write a constant. And what's that constant? That constant is omega squared, right? So this is like the new and improved version of the icon. Is that clear? Clear or not clear, everyone? Okay, so in SHM, A is equal to minus omega squared x. As usual, if you are not taking origin as mean position, then instead of this you get delta. That is, don't be surprised if sometimes we have to do this. Okay, it doesn't make any difference, right? Well, now let's go to another relation here. So, if you would consider what we have discussed so far, this point, at this point here, this line. Do you see this is a relation of A with T? Yes or no? So we have derived two things so far. Relation of A with T, that is acceleration with time. Clear? This one. Okay? And this is relation of A with position. The second one is relation of A, that is acceleration with position x. Fine. Okay, again I'd say this is more important. Okay, this is like you should remember this. Okay, but even this one, if you know, it's good, right? So this is what we have done. Now we are going over to the next thing, and that is we will draw graphs of these things. Okay, first let's discuss what happens at various points. Okay, this one. Right, let's say at mean position. Okay, at mean position, we know that x is 0. If x is 0, obviously A is also 0. Clear or not clear? Right? No? I hope it was not tough. At mean position, if you put x is 0, obviously if you put 0 here, 0 into anything is 0. Come on, I should not have to say this. Okay, so here obviously the acceleration is 0. Now, what happens? So this is the minimum acceleration, you can say, right? Or no acceleration, right? Okay. And this would of course also mean that external force total is also 0. This we have already talked about, right? Then what happens at extreme position? What happens at extreme position? Let's say suppose E. So x equal to plus a. If x is equal to plus a, acceleration is minus omega square a. Clear or not clear? Acceleration is minus omega square a. हैंड रेज करी था कि क्या लगा? हाँ, तो હવે બીજી વાર પૂછ્યું નહીં. જવા દો ધડાધડ. Okay, so a is minus omega square a. What does this minus indicate? Have a look here. When the particle is over here, that is its displacement from mean position is towards the right hand side. Is that clear? Okay, so the acceleration will be in opposite direction, right? Acceleration is in opposite direction to the displacement. That's why the acceleration is towards left side. That's what this my sign is telling, right? The acceleration is towards the left side because this is at extreme position E or x equal to plus. Now just like this, if it were at E dash, okay, wait quickly, x equal to minus a. Isn't it? So a is equal to, what do you think? If x is equal to minus a, what is a equal to? We should say, yes, omega square a, very good. Omega square a. So why so? Again, if the particle is here at E dash, then the displacement from mean position is towards left side, and that means the acceleration will be towards the right side. Okay? So, do you realize that minus or plus, either way, only indicates direction? Correct? Minus or plus is only indicating the direction of acceleration. So if I want to find out maximum magnitude of acceleration, if I want to find out maximum magnitude of acceleration, that is nothing but a max. Correct? What do you think it will be? Omega is a constant. So we should put x as maximum in value, that is plus a, because from here you can only go up to a distance a on either side for a second, right? So a max is equal to omega square a, and this is at which position? When you put x equal to plus a or minus a, anything. So this is at, it happens at extreme position. Is this block clear to you? Is this block clear to you? Okay? So, where is the velocity, or sorry, where is the speed maximum? At mean position. That is, V max is omega into a. Where is the acceleration magnitude maximum? At extreme position, that is omega square into a. Clear? Omega square into a is the maximum acceleration magnitude. Got it? It is at extreme position, either one, this or that, both. Now, based on this, you might have a question like, physically, why is acceleration maximum at extreme position? The reason is actually very simple. It's that if you remember, simple harmonic motion is characterized by this. Do you remember this? Or delta x? Do you remember at start we talked about this? Simple harmonic motion is characterized by that. Right? So what that means is the more the displacement, the more the force, total force. Clear? And obviously more the total force, more the acceleration. So when this goes far, okay, there the acceleration will be maximum because force, total force will also be maximum. Understood? અરે ગ્રેસી બરાબર વાંચીને તો ક્વેશ્ચન પૂછ. અહીંયા શું લખ્યું છે? Okay. So this is the reason why acceleration's magnitude is maximum at the extreme positions. Okay. Now, we just have 1 or 2 minutes, right? Let's draw a graph now. First for V and then for A. I will not explain a lot about the graph today. You try to think about it on your own. Okay? So let's begin. So first of all, graph of V versus T. And I am doing this again for phi 0 equal to 0. So V is equal to A omega cos omega T. Understood? What happened to phi 0? It's 0. Right? So using this relation I am going to draw the graph. Okay? So at T equal to 0. At T equal to 0. Cos 0. Cos 0 is 1. So you start from plus A omega. Right? And see, just like we will have this kind of relation. Okay? So sin or cos, the pattern of the graph remains the same. I repeat, the pattern of the graph remains same. So we start at A omega. Then after some time when we reach T by 4, when time is T by 4, V is equal to A omega cos, what's this carefully? Omega is 2 pi by capital T and small t is T by 4, time period by 4. T cancelled, 2 cancel, pi by 2, cos pi by 2 is 0. So basically I just want to give you the idea that the graph will follow similar shape as we have for position. Did you understand this? Yes or no? Okay? Pattern is the same. Okay, so those who have not understood, don't worry. I am giving you time to think about it. Okay? Alright? And we will answer your questions tomorrow if you have anything. Right? You can check all these points, that is how much is velocity at T by 2. How to do that? By putting T by 2 here and doing some maths. Right? That's the procedure. Think how we have drawn the graph of X. By using same procedure, you can draw graph of V also. Okay? So we'll discuss it if you have any doubts further tomorrow. Right? Goodbye.